4% increase and decrease, but now we're going to work in, well, exponential growth and exponential decay, but now we're going to work in the percentages that we reviewed in the last lesson, okay? So if you recall, we reviewed this yesterday. If I have y equals a times b to the x, right, that thing, that b, when is this growth? And b is what?
Greater than 1.
Greater than 1, right? And when does it decay? Yeah, between 0, what? B, yep. And b is between 0 and 1, like a half, or 0.8, or something like that, right?
What's negative?
We're not going to get into that. That's a wild ride.
Wait, can you just say what it does?
Yep, and we're
I
going
thought that was a cockroach.
to... Anyway.
I don't know, like a beetle.
So, agronomists, I guess that's what they're called, are studying population of beetles. And this population increases very quickly, exponentially, right? Remember, exponential growth happens very fast, okay? So they calculate the population is increasing at a stated rate of 6% per week. So what number will we actually be using for calculations?
6%.
Nope. 0.06, right? At the beginning of the week, the population was 350 beetles, so that's like the starting amount, okay? So, all right, find the population of beetles after a week later by finding 6% of 350 and adding it to the, well, how do we find 6% of 350?
You just multiply.
350 times what? 0.06. And what does that give you? Push buttons.
Exact 21.
21 more beetles, right? Is that the answer to the question?
Yeah.
No, because we started with how many? So what do we have to do to find how many there? So now 350 plus 21 is 371 beetles. So kind of a two-step deal, right?
Oh, well, this is kind of easy.
Well, it gets even easier than this. So you notice I took one of the 350 units, if I want to say it that way, and then 6% of 350, right? Isn't this 1 times 350 right here that I'm pointing at? And isn't this 0.06 times 350? Isn't this 1 plus 0.06 times 350?
Why not?
Why not? Exactly, right? That's out of there. So in part B, so watch this little shortcut. And actually this shortcut you learn has massive uses in finance and other things. Find the population of beetles a week later by a single multiplication. So instead of multiplying it by 6% and then going back and adding that to itself again, I'm going to multiply the 350 times itself one time, right? You with me? Plus times 6% of itself. See what I mean?
So 1.06.
So we can simplify that as 350 times 1.06. Now, by the way, is that number greater than 1?
Yeah.
So if this was, yeah, if it was exponential, it would be, right? We'll get to that.
Oh, and
so
the beetle population of 206, right?
you could probably square that.
Huh?
You could probably square that because you'd be multiplying by that twice. Oh, yeah. So what is that? Put that in your calculator. Tell me what you get.
371.
You get the 371, right? Same answer, right?
Yeah.
But this way, like we combined both of those steps into one, right? Here's one of the 350s right here. 350 times 1 is 350 plus 6% of the 350. It's all wrapped up in the one thing. Do you get that? Okay. So what will the beetle population be after 2 weeks? Well, what should we do? Take this here. Well, we'll do that in a minute.
2,921.06.
So let's take the new, this is after a week, 371, right, times
Times 1.06.
1.06 again. And what do you got?
$393.26.
393.26. Does that make, so we need
No,
to
you
adjust
can't
that a
have-
little, right?
You can't like, have a quarter of a.
Yeah, I mean, you could like pull the wings
No,
off and
but
stuff,
over.
probably. So really you'd have
That's what he needs to know.
396 beetles in 2 weeks.
396.
Or 93, 393. Well, you're not gonna get the full, no, it's gonna be 393. Right?
Do you know why there is beetle born?
I don't know.
Like when people shoot bears and everything in deer, they take them there so like the meat and skull.
Okay. Anyway.
I don't know. I said my.
So what did we, so we multiply, so basically we multiplied the starting amount by 1.06 how many times for the second week? Once there and once there, right? So now you probably thinking we could set this up as like an exponential if you wanted to, right? Well, let's just do, what would it be?
350.
It'd be y equals 350. That's the a, the y-intercept, times what? 1.06 to the, we'll use a w for number of weeks maybe, right? Instead of an x. So then you could plug in and say, all right, what's the population going to be after 10 weeks? You just put a 10 in for w and push buttons, right? It's going to be at 350 times 1.06 times itself 10 times. All right, so let's go on to exercise 2. Find the result of each of the following. All right. It says do not round. If it becomes a ridiculously long decimal, we'll let the round. But now, they're not saying multiply 440 by 12%. We did that in the last lesson, right? Increase it by 12%. So thinking about what we just did, we'll start with 440 times what? 1 plus 0.12. Because it's saying to increase it. So it's a little different than yesterday. So to increase it by 12%, right, the long way would be to find, all right, what's 12% of 440, and then add 440 to that, right? But isn't this just 440 times 1.12? And what does that give you?
A number.
Yeah, tell me what that number is.
492.8.
492.8. Right? So do you see doing it this way does those 2 steps all in one? Like this up, see? Up here was 2 steps, no, up here, sorry. Up here was 2 steps. Down here was just 1. So you guys go ahead and take a second and do B and C, all right? Remember, you're not just multiplying by 8%, you're increasing it by 8%. All right? Everybody do that right now. B and C. Is this what you'd multiply by, guys? What I have here? Yes or no?
Yeah.
Yeah, 1 plus 0.08, right? What'd you get? 73.44. Okay? And C. Hmm? Yeah, make sure you get your 8%.
448.68.
Oh, well, that's a different issue. Yeah. Kimmy, what do you have for C? What do you guys think of that? 124.2?
I got 162.
Got 162. What'd you get? Another 124.2. It's 124.2. What'd you multiply by?
120 times 1.5.
You got to move it twice. Not once, twice. Right? So 120 times 1.035. I'm skipping where you do the 1 plus, right? I hope you get that. And it was 124.2? Okay? Right. This, I mean, you guys get where I get 1 point at, because I'm just not doing the separate 1 plus. Isn't that kind of obvious? And again, when I do 1 plus, doesn't it make this b greater than 1 for growth? And maybe at some point, we'll end up doing 1 minus, like if something is getting smaller, right? And 1 minus, like 0.08 would be 0.01, wouldn't it? Just thinking ahead. All right, exercise 3. Adriana, savings account. Pays 2.5% interest per year. Does anybody here have a savings account? Somebody, does it pay, you pay interest, you get a statement each month? Maybe it says how much they added to it. Yeah, right? And it's just sitting there and it's making money and you're just playing video games and money's showing up in your account. It's called interest. Anybody know why they pay you to do that? Put their money? So yeah, where do banks, I won't get a little off topic, but where do banks make money, you know? Hmm? What happens if you need to borrow money instead of buy a car or a house? You go to the bank, get a loan, and so if you borrow $10,000, is that exactly what you pay back? Oh, you pay interest back, right? Maybe you pay 5% interest on that $10,000, right? And that's their incentive to loan you the money, and you need the money now, so you agree to pay the extra 5%, right? And where do they get that money, that $10,000 to loan you? And the savings account. And others, right? And other accounts, obviously, unless you got $10,000 in there. Anyway, so she deposits $720 at the beginning of the year. Okay? What would be her balance at the end of the year? So basically adding 2.5% to what number? Okay, so what will it be? We're going to do 720 times what, kids? 1, let's just do point. I know it's plus. 0.25, right? How much is that? Anybody press a button on their calculator? Huh? $738. Just for sitting there, not doing anything. Yeah? We good so far? Okay. Let's look at going the other way. This is a little bit like growth, right? But we didn't really quite get exponential about it yet. Let's look at something that gets smaller. Cup of coffee or a cup of hot tea or something, right? What happens when you have a hot cup of something and it's sitting in a room? What happens to the temperature? It cools down, right? Right? It starts to approach room temperature, right? Huh? Yeah, it does evaporate, but that's insignificant for the time it takes to cool down to get to room temperature, right? So it's cooling down such that a temperature is decreasing at a constant rate of 8% per minute. So every minute it gets 8% cooler. Okay? Let's say the coffee starts at 200 degrees Fahrenheit. Wow, how? Shit. You're going to want to let it sit there, boy. 200? Okay. Another 12 degrees, it'll be boiling. All right, find its temperature after 1 minute. So let's do this. By finding 8% of 200 and then subtracting it. So how do we find 8% of the starting temperature, 200? 200 times what? 0.08. And that's 16. So it dropped 16 degrees, right? So what's the new temperature? 200 minus 16 gives you what? 280, no. How about 100?
184, not 180.
184 degrees. Okay, after 1 minute, so it's cooling off. Okay? Now, let's think of this a different way.
Yeah, change the coffee temperature.
Yeah. So for part B, we want, you know how on the other page we're doing like 1 plus the rate for the increase? Well, okay. Yes, but I want to ask you what? So think of it this way. If something decreases by 8%, how much remains? 92%. You get that? If something decreases by 5%, how much of it remains? 95% remains, right? How'd you do that? From 100, right? But if we're coming out of percents, right, we're not doing 100 minus. What's 100 divided by 100? Because we always take our percents. 1. So not 100 minus, but what minus? 1 minus. Does that make sense? Okay. So think of it this way. If we so a decrease of 8% implies that how much remains? 92% remains. What's 92% as a decimal we can use mathematically? Nope. Try again. Move the decimal twice. 0.92, right? Well, anyway, so we'd start with 200 times, well, itself minus 0.08, right? And what's 1 minus 0.08? Come again? 0.92. So what's 200 times 0.92? Hey, how about that? The same we got up there. 184 degrees. So you see the distinction here? All right, and by the way, if this is like, if we were going to set this up exponential, if this is a times b to the x, what do you notice about the b here?
It's 92.
Right. No, it's not 92. 0.92.
92.
No, this b. What do we notice about the value of b? It's between what? 0 and 1, which makes it what? Decay, right? So for the growth, it was 1 plus some number, which made it greater than 1, right? Isn't it consistent with what you know about b? And for decay, it's 1 minus the rate. So decay, okay? What will the temperature be of the coffee after 2 minutes? Well, here it is after 1 minute. So we can just do this thing again, can't we? So 184 times what? 92% of that remains, right? And what's that give you?
77.
No, 169. Right?
Yeah.
Okay. Maybe.
I think this is here.
Okay? So for growth, like percent growth, it looks like it's 1 plus the percent rate. And for percent decay, it's what? 1 minus the percent rate, right? The decay rate, right? So decreasing within the school to be fluent, blah, blah, blah. They say a lot of silly stuff here. All right, so let's survive. The enrollment of students in the school is decreasing. How quickly? 5% per year. So why don't you guys figure out what remains after 1 year? Let's see. Well, let me just, oh, okay, yeah. What percent remains after 1 year? How'd you get that? 100% minus 5% equals 95% remain. Okay? But if we divide both of these here, right here, by 100, wouldn't that be 1 minus 0.05? Which would be 0.95, which is the same as dividing this one by 100, right? So in part B, do they give us a starting population? Okay. and they want to know what it will be next year. What are you going to do? 2,300 times what? 95% of it, right? Because that's what stays. That's what remains. What do you got? Say it.
1,185.
Well, that's a little bit less than 2,300. Seems about 95% of it, right?
Yeah, but I've been wrong with it.
Well, that's okay. So 2,185 is what's left. Okay? Okay, exercise 6. All right, so you think you get the hang of it now, maybe?
That one is a bit easy.
So you guys go ahead and do A, B, and C, okay? Show where you multiply 620 by. It's decreasing, right? So it's going to be 1 minus the rate, right? So everyone take a minute and set up A, B, and C. What do we get for A?
558.
So 620 times 0.90, right, or just 0.9 is 558. We all good with that?
So that'd be 1 minus 0.5.
Yeah, that's 0.9. I just didn't do the 1 minus. You want to do the 1 minus? All right, 1 minus 0.10, which is in fact 620 times 0.9, which equals 558. How about part B?
147.
Well, for the units, they give you units for this one. Yeah. It's money. You're multiplying it by what? 0.92. And what's the result? That's what I'm, yes, thank you. Was it 20? Yeah. $20.70. How about C?
117.73.
So it's 122. Let's make sure we're clear on what this is, right? Times 1 minus what? 0.035, which is actually 122 times what? .965, right? Which is, what did we say it was? 0.73. Okay? All right, last one here. Cost of gasoline decreased recently by 4.5. I wish that was true, percent. Started at 3.80 per gallon. What's the new price? I'll let you guys figure that out. 3.80 times 1 minus something. Go ahead. What's the answer? You guys get choice 1? So it's 1 minus what number exactly?
0.045.
0.045, which is actually 380 times what? Point. Anybody? 1 minus? You got a calculator in front of you. I mean, geez. Not 55, no. 0.955, right? And that's 363. All right? Kind of getting the idea here? So we're setting up exponential and exponential growth and exponential decay models here, right? Let me give you a quick, just a quick summary of what we learned here. Okay? So, if like R, what is this? What is that? What is that doing? Why? Okay. Let's say that R is the rate at which something is increasing or decreasing, right? So if R equals rate of increase or decrease, okay? Of some quantity A, right? Some initial amount of something, A, okay? For percent increase, welcome back. It would be that amount times what? One increase. One plus whatever that rate is, right? You know, decimal. And for percent decrease, it'd be our starting amount, A, times what? 1 minus the rate, just like we've been doing. Okay? Now you can probably imagine we'll put an exponent on there. Because if something increases a certain amount over a certain period, a certain number of times, we just put that number into the exponent. Okay? All right.